Dear students, welcome back to another video session on three-phase circuits. In the previous video, we were analyzing three-phase balanced delta connected loads. In this video, we will be analyzing a three-phase balanced star connected loads. Already we have seen what kind of analysis are we going to do. It is actually finding the phase currents and line currents drawn by the load, power drawn or absorbed by the load, and then we will find the power factor. These are the kinds of analysis we are going to do. So let us consider a balanced three-phase star connected load. So here the load is connected in star. So since it is called balanced load, so all the loads are having same value Z at an angle phi, where Z is the impedance connected to that particular phase and phi is the angle between the particular phase voltage and the phase current. So the entire system is connected to a three-phase balanced system. So three-phase balanced system is supplying this balanced load, and here in star connection the line voltage and phase voltages are different. Hence the supply line voltages will not be equal to load phase voltages. So current flowing through the phase is equal to the current flowing through the line. So you can see in star connection the phase currents and line currents are same. Hence, so the current flowing through the line IR will be equal to the current flowing through the phase IR, and so on. The three line currents and phase currents we represent as IR, IY and IB. So let us try to find those currents. So consider only the two phases connected between R and Y for simplicity. So by applying Kirchhoff's voltage equation for this loop, we can write VRY minus this voltage is VRN, and the voltage across this phase is VYN, and since we are ending with plus, we will write plus VYN equal to 0. Therefore VRY is equal to VRN minus VYN. So if you know the values of VRN and minus VYN, we can find VRY. Similarly, the other two line voltages can also be written like this. Now keeping this in mind, let us draw the vector diagram. So let us take the phase voltages as reference. So VRN, VYN and VBN all are equal in value magnitude, and they are displaced by 120 degree from each other since it is a balanced system. So VRY is equal to VRN minus VYN. So we need VRN vector and minus VYN vector. So we will draw the opposite vectors as minus. So now we have got VRN and minus VYN. So if you draw the resultant vector using parallelogram, you will get the resultant vector VRY. Yes, so this is the resultant vector VRY. Now using parallelogram law of forces, we can derive the expression for the resultant vector VRY as VRN square plus VYN square plus 2VRN VYN. So sorry, here it is VYN, and the angle between them will be 60 degree. So the angle between them will be, here it is 60 degree, and so here all the phase voltages VRN, VYN, VBN are same. Therefore I will use a common term VPH. Similarly, all the line voltages are same, so I can use a common term VL, and after further simplification I will get the line voltage is equal to root 3 times phase voltage. So this is the relationship between the line voltage and phase voltage in a star connected network. Similarly, I can draw the other two vectors VYB and VBR by joining the vectors like this. So VBR. So this is the relationship between line voltage and phase voltage. Now let us try to find the currents. So first let us find the currents IR, IY, IB. So what is IR? IR is the current flowing through R phase. So I is equal to V by Z. So what is the voltage across this R phase? It is VRN, and this impedance is Z at an angle phi. Therefore, and the source voltages you can write it as VRY. Usually while solving problem they will give the source voltage as a line voltage mostly, and we will have to write in this form. Hence from this we need to find the phase voltage. So already we derived VL equal to root 3 V phase. Therefore V phase will be equal to VL by root 3. So all the three phase voltages can be written like this. Now what is IR? After finding the phase voltage, just divide the voltage by its respective impedance. So this is how we can find the line currents and phase currents. Both are same in this case. Now, a three-phase balanced star connected load of 15 plus J20 is connected to a 440 volt three-phase balanced supply. Find the line currents and power absorbed by the load. So this is a three-phase star connected load where all the loads are having equal values, and the system voltage is now 440 volt. So the phase voltages are VRN is equal to line voltage by root 3. So you can write all the three phase voltages. So the magnitude will be same, only thing is the angle will be different, and the impedance of the phase will be, you can convert that into polar form, 25 at an angle 53.13 ohms. Now what is the current? Simply phase voltage by the impedance. So phase voltage is 254 at an angle 0 and the impedance is 25 at an angle 53.13. When you take this 53 to the numerator, it will become minus. Similarly IY, voltage across Y phase divided by its impedance. Only difference is here it is minus 120 since it is a balanced supply. And then IB. So these are the three line currents as well as phase currents. Now let us find the power drawn by the load. The formula is root 3 VLIL cos phi. So VL is 440 and IL, you can take the magnitude of this current, any of this current, any three currents, it is 10.16 and the angle is 53.13. From impedance value you can take this angle and the answer is 4645.78 watts. Thank you.